Welcome to the short introduction to Bentley's construction solution. During this brief presentation, we will look at what the construction solution has to offer, but before we do, we first need to understand what the software is. The construction solution is a project/construction management tool that has been developed in accordance with both lean construction and last planner ideals. The software is a graphically enabled integration system that brings data together from various sources. For example, CAD data, planning/scheduling information, material management data, as well as information from commissioning systems, etc. This data is combined into a single virtual construction model, which is often referred to as the single source of truth. The software is an extremely flexible status visualization tool that allows the user to break the model down by any required permutation, as well as allowing schedule simulation, reportings on construction, completions and commissioning. It is also a graphically driven workface planning tool that can improve field productivity by between 7 and 25% and save between 1 and 5% of the total installation cost. This may seem a bold statement to make, however, during this short presentation, we will show you how this can be achieved. As we mentioned earlier, the software is able to import data from various sources. In this particular example, we can see a combination of data from various Bentley solutions, including equipment, foundation and pipe from Open Plant. We have cable raceway from BRCM, and finally structural information from Pro Structure. And we can focus on each of these disciplines, for example, equipment. As we look at the construction model, we can see the data as it was originally designed. And although this is useful, it does not lend itself to effective planning or construction. In order to address this, one of the key functions of the software is its ability to break the model down using attributes. In this particular model, we have configured the software to show various user-defined groups. For example, construction work areas, system breakdown, and construction work packs. If we focus in on one of the construction work areas, we can see the software displays all the relevant components with this particular area. The reason we do this is to allow the planning/construction team to plan more effectively. It also allows the user to focus in on key areas of interest and not concern themselves with the larger model. As we mentioned earlier, the software can be used across the complete project life cycle, and we will now show how it can be used during the early planning stage. To do this, we will focus on the combined hydro treater unit. Another key function of the software is status visualization, and we will now use this to show the ETA dates for both the pipe and the equipment within this area. This information would be exported from a material management system, for example, Smart Plant Materials. And from this information, we will now colour the model to show the ETA dates for both pipe and equipment. In doing so, we may have highlighted an issue. In this example, we have 4 heat exchangers, 3 of which are scheduled to be delivered in January. The 4th, however, is not scheduled to arrive until February. And the question we need to ask is why. If the heat exchangers are being supplied by the same company and the 4th is in stock and ready to be shipped with the others, it would make more sense to ship them all together and therefore save on shipping costs. This will also ensure that we remove the risk of the 4th being delayed later. And as we can see on the model, this is especially important as it is actually being installed first. The next key function we will look at is working with scheduling information. The software allows the user to both import a schedule or create one on the fly and link the tasks to the relevant graphics. In doing so, the schedule can be played back in real time and the construction sequence validated. In this particular example, the schedule is due to begin in January and run through until mid-May. As we start to review the schedule, we can see the screen is empty. However, as we play the schedule back, we can see the components are added based on their schedule installation date. In this particular example, starting with foundations. As we move forward, we are looking for obvious issues with the construction stroke installation sequence. And we may have found one. It would appear that this pipe is being installed unsupported and not connected. We will make a note of this and monitor it as we go forward. As we continue, we may have identified another issue. It would appear that the heat exchangers are being installed out of sequence, with the top one being installed before the bottom one. And this is obviously incorrect, and again we will make a note. This is a simple system to use, and there's no need to understand how Primavera works or have any past experience with scheduling or planning. All that is required is common sense and a basic understanding of what a typical installation stroke construction workflow is. If we cast our mind back to the pipes we identified earlier, we can now see that it is being connected to one of the fans, and we may need to adjust this installation sequence. So, in this quick example, we've highlighted 2 separate issues, and we can now decide a plan of action. We can either modify the schedule inside of the software and rerun this to validate what we have done is correct, or inform the planning team so they can address it in Primavera. Now that we have validated the schedule, we will now put our construction hats on and focus on early planning when it comes to a typical pipe installation workflow. To do this, we will focus on a key area of the hydro treater unit. When looking at pipe installation, the construction teams follow a typical workflow, which we will now duplicate. And to do this, we will once again use status visualization. We will start by identifying priorities. As we can see, the project has 3 phases. The first of which is highlighted in red, and we can quickly identify which pipe work belongs to phase 1. The team now knows the priorities and we can now focus on these. The next stage is to check whether the drawings have been issued for construction, and again we will colour the model using status visualization. As we can see, all the priority pipes are IFC'd, so we can move forward. Our next step is to check material allocation, and once again we'll use data exported from a material management system, for example Smart Plant Materials. As we check the model, we may have identified a problem, as one of the priority pipes does not have full allocation of materials. We need to understand why this is the case, and we would now call the material management team to discuss this. During this conversation, we discover that the reason the pipe does not have full allocation is due to the valve not being available. As this valve is an erection item, by this we mean it will be installed on site, it will not stop us fabricating the pipe or indeed installing the rest of the pipe. So we can instruct the material management team to allocate the remaining materials. This is especially important as following further checks, we discover that the pipe needs to be installed so we can carry out a site weld further down the line. And this site weld is key to positioning a piece of equipment. This done, we can now move forward and look at the spool fabrication status. As we can see, the pipe we identified earlier is currently on hold, which makes sense as no materials have been allocated. However, as we have now identified why this is the case, we can now rest assured that the materials will be allocated and the spooling will be carried out. Although this is the case, we still need to monitor this and ensure the materials are released and the pipe fabricated by checking the model regularly. So far we have focused on piping, but what we now need to do is take a step back and look at the bigger picture. To do this, we will ask the software to show the current status of all the components within this area. This way we can see the priority pipes along with any dependencies. As we can see, the pipework and the pumps are on time. However, let's take a step back and look at the bigger picture. We're now looking at the model, and it would appear that one of the heat exchangers seems to be delayed. Let's zoom in and take a closer look.